Hello, welcome to LEMIS, where we help you discover your passion for math. Today, we will be teaching you how to set up a truth table. I am Julibien Orelle S, Padel, and I will be your teacher for today. In setting up a truth table, we have to consider the propositions P, Q, R, Z. And looking at the screen, can you tell me how many propositions are there? If you say 4, then you're right. Specifically, we have to consider the number of propositions. Why? Because the number of propositions will determine the number of rows we'll need for the truth table. So let's have an example. Let us set up a truth table for not P, and if P, then Q. To determine how many rows we'll need, we'll use the formula 2 raised to n, where n is the number of propositions. So for this example, we have P and Q, which means it's 2 raised to 2 because we have P and Q, which is 2 propositions. So that means we need 4 rows, and this is excluding the header. Now, let's start constructing the truth table. For step 1, we create a table with the propositions and the correct number of rows. So we have P and Q and 4 rows below it. Now that we already made the truth table with the correct number of rows, we'll start writing the T and F on the rows or the cells. To do that, we'll do the thing I like to call the halves of halves. Now take note that this is not an official term, but only a term I like to use when starting a truth table. So what does this mean? Let's see. Let's start with the letter P. We have 4 cells under it, so we put T on the first half, and then F on the second half. That's half of half. Now, Q. Let's focus on the first half, which is the 2 cells with T. Then we put T on the first half, and then F on the second half. Then we do the same on the next half of F. See what we did? We half and then we half. That's why we like to call it the halves of halves. Now, this is also what you need to do if we have PQR or more than 2 propositions. We half and then half until we reach the point where the T and F alternates. Now let's try to finish this by breaking down the compound propositions into sections, starting with the not P, which is simply negating the truth value of the original P. So since P is TTFF, not P will be FFTT. See? We simply made the value the opposite. So if it's T, we make it F and vice versa. Then, we move on to if P, then Q. Now remember, to know the truth value of the compound proposition, we follow these rules. OR is true if at least one is true. AND is true if both are true. XOR is true if exactly one is true. Meanwhile, implication has a lot of instances where it is true. That's why in the rules, we focus on the false. And an implication is false if the P is true and the Q is false. And lastly, we have biconditional, which is true if both are true or both are false. And if we follow the rule of the implication, only the second row is false, while the rest are true. Lastly, we combine. And because its propositional connective is AND, it is true if both are true, which means only the third row and fourth row is true and the rest are false. And there you have it. You have your truth table. Thank you and see you on our next tutorial. Bye-bye!